So in lecture, we got through most of the PowerPoint, kind of ending up, we were discussing how diseases get into the body, kind of some basic terms when we talk about various diseases. The rest of this PowerPoint is really talking about how do they actually cause infection? What makes certain microbes more infectious than another? Kind of what are some tricky ways they can go around it? And then when we're starting to talk about diseases, what are things that we have to be concerned about, and how can we prevent the spread of these different diseases? So for the how do pathogens actually cause infection, there's two terms that we refer to. One is pathogenicity, which just means this is the ability of a microorganism to cause a disease. If a microorganism cannot cause a disease, we do not consider it pathogenic. Which means it can't cause a disease. It's generally not a concern of ours. And so that's just, can it cause a disease or not? Virulence talks about what is the degree of its pathogenicity. And so what is its degree of disease? Is it a deadly disease? And can it easily cause disease? Does it take just one or two microbes, and that's enough to cause a disease? Or is it, pretty hard to cause a disease unless you're immunocompromised or you have a big dose of this microbe? And that all comes down to these virulence factors. And so virulence factors contribute to how easily a microbe can cause a disease. And and that depends on the microbe, whether it has some of these little factors or not. One are adhesion factors. It's pretty much, can it stick? That's the adhesion part. Can it stick? And again, most microbes have to stick somewhere. They have to call themselves a home, whether it's a bacteria on a surface or whether it's a virus sticking to the correct cell and getting in. And does it have these adhesion factors to stick? Can it form a biofilm? And the more likely it can form a biofilm, the more likely it can cause a disease because it's harder to get rid of. Can it make extracellular enzymes? And I've got a couple slides on these next three. Can it make extracellular enzymes, which a lot of times is used to destroy tissues to get in and then cause disease? Can it produce toxins that damage cells? Again, a way to get in. And can it make anti-phagocytic factors? A lot of the times for us to get rid of pathogens, we have phagocytes. We have our white blood cells that go around and eat these foreign objects. Well, some of these microbes, these foreign objects, have figured out ways around that. Now, since virulence factors contribute to disease, and my question is, so how many virulence factors would normal flora, your normal happy bacteria hanging out in and on you, typically have? It's generally few to none. And they're not there to cause disease. And you're right, in certain areas they could get different places they're not supposed to, but really they don't have very many virulence factors. They don't cause disease very easily. This is just showing some various diseases that you may have heard of, and virulence or not virulent. Now, virulent, again, just means it's more able to cause a disease. It doesn't happen, that disease itself doesn't have to be a deadly disease. It just means it causes the disease easily. And so rabbit fever, and all it takes is just a few of these microbes and you have it. But you're right, the main symptom is a fever, not that bad. But it's extremely virulent. It can get in really easily and cause you to have a fever. The plague is quite virulent, and unfortunately it can be deadly. Whooping cough is pretty virulent, again, can easily get in and cause diseases. As we go through some of these other ones less virulent, C. diff, there's your Clostridium. Again, it's not the most virulent, and a lot of our normal flora keep it in check. All the way down to Candida, your yeast, Lactobacillus. Again, it's usually you have to have high quantities of these, like large amounts of these, or immunocompromised state for these to cause disease. Now, some of those virulence factors, those last three that were on that list. One is, does a microbe have extracellular enzymes? Which means, can it secrete these enzymes? Now, generally what these enzymes do is dissolve some type of structural chemical in the body. This is showing, here's epithelial cells. This could easily be skin cells. This could be anything lining our digestive tract. But if the bacteria gets in And I'm like, it has to make it past this barrier, these epithelial barrier line, and even that collagen. Well, if this bacteria can make an enzyme called hyaluronidase, it right away just destroys. And I'm like, the structures that hold the cells together, which means now the bacteria have an entry source. And bacteria can start penetrating into new parts of the body. So it's great. And I'm like, also bacteria can make enzymes, and I'm like, called coagulase, which, yes, coagulate means blood clotting. Well, bacteria can actually cause blood clots to form, or clots. And I'm like, which is great for the bacteria because the bacteria actually hide themselves in these clots. It's almost like they made their own protective little shell. Our body sees the clot as something normal, and I'm like, it's something that is not foreign, but there's bacteria hiding inside of it, multiplying. Later, when the bacteria want out, they can make an enzyme, another enzyme called kinase, and break it down, and then they can get wherever they need to go. So they can kind of travel around in the body in these clots. And so they help maintain infection, they can avoid, and they can be sneaky and avoid our immune system. And I wrote the definitions in here, so you can pause me if you want for writing all these down. And I'm like, but another virulence factors is, does a microbe have some type of toxin? Which a toxin is just a chemical that can harm the tissue or cause some other type of immune response that would still then cause tissue. Now, when we talk about toxins, there's kind of two groups of toxins, exotoxins and endotoxins. Exo means out. These are chemicals that are secreted by a microbe, sent out, and it's generally to destroy a cell or somehow cause some type of damage. An endotoxin. These are those toxins that are made within the microbe, specifically gram-negatives in their outer membrane. And it can cause fever, inflammation, blood clotting, and even death. And so I'm like, but it's maintained inside of their outer membrane. So this is showing a bacteria that's making that exotoxin. And so there's your little bacillus-shaped bacteria making this exotoxin that are destroying host cells. Again, allowing them entry. And I'm like, this is showing one, and I'm like, that here you have some gram-negative bacteria that are getting broken down, and as they get broken down, that outer membrane releases that endotoxin. And yes, it can get into our blood supply, and yes, cause all of these additional factors, which bad for us, but good because the bacteria can spread wherever they need to go, and I'm like, can cause more damage. Another virulence factor are antiphagocytic factors, which pretty much mean they're going to prevent phagocytosis. If you're a bacteria, you do not want to get eaten. So they've figured out a couple ways to prevent that. One, if bacteria have a capsule is an antiphagocytic factor. And I'm like, there's two reasons. One, it's composed of a chemical that's not recognized as foreign. That capsule is made of sugar. And I'm like, in sugar units that our immune system recognizes that's normal, so we don't need to fight it off. Also, and I'm like, the actual capsule itself is a little bit slippery and difficult to engulf if you're a phagocyte. And so it may try to engulf it, and then it's like, nope, you slipped right out and it got out. Bacteria lives, good for it, bad for us. Also, they can make various chemicals. One that prevents the fusion of the lysosome and that phagocytic vesicle. And this is a picture showing what that looks like. And I'm like, that you have a big old phagocyte, big old monocyte most likely, and it just ate. And I'm like, this big vesicle, and there's your bacteria in there. However, this particular bacteria makes a chemical that the lysosome, whose job is to break down things, including bacteria, it can't fuse to that vesicle. And I can't break it down. And so now you just have this bacteria found itself a new home. It's living inside of a white blood cell. And if you can have a bacteria living inside of a white blood cell, nothing's going to eat it. It's living in this white blood cell, and I'm like, it's not getting recognized as foreign, and it will do what it does best and reproduce inside of our white blood cells. Also, there are some microbes that can make what are called leukocytins, which just means it's a chemical that they can kill phagocytic white blood cells. If you know that these phagocytic white blood cells are after you, and I'm like, well, they've made chemicals to then damage and destroy them. So lots of things that can help make these various microbes virulent and able to cause disease. Now, so if we get something in, there are 5 stages of an infectious disease, and you have probably all gone through these at some point with some type of disease. So the 5 stages, the first stage is called the incubation period, where someone coughed on you, sneezed on you, and you walked away, and really, even though a virus got in or a bacteria got in, you really didn't know at the time. And I'm like, because that virus or bacteria is just starting, to find a home, to start to reproduce, and it's during that incubation period, you don't really have any signs or symptoms yet that you're sick. And I'm like, you're infected, but you don't know that yet because you don't have any signs or symptoms. Now, the prodromal period, and that time that you have that incubation period can completely vary. It could be a few hours depending on the organism, it could be a couple days. The prodromal period is when you're starting to get some vague general symptoms. You're kind of feeling muscle aches, maybe a little tired. Sometimes you've woken up before and you're like, I just feel off today. You're probably in a prodromal period and your body's realizing there's something going on. The illness stage is this when you have the most severe signs and symptoms, whether it is your vomiting or diarrhea or fever. And I'm like, whatever it is, these are your most severe signs and symptoms. It's generally when you go to the doctor, and really your immune system at this point hasn't really kicked in yet. I'm like, it's activated for sure. It realizes there's something going on, but it hasn't really mounted a full response. It's definitely not winning. The decline phase, though, this is when the immune system is starting to win. It is now killing more microbes than the microbes are making as they reproduce. And I'm like, you're starting to feel a little bit better. Your fever might not be as bad. And I'm like, you're starting to feel better. And then the convalescence is when you don't have any signs or symptoms at all. Everything's kind of getting repaired, getting back to normal. And I'm like, it doesn't mean every single microbe is gone out of your body, but at least you're feeling normal again. So kind of 5 stages. You probably can imagine yourself going through these, maybe recently, going through all 5 of these stages. Oh, I have my little numbers that came up. And I'm like, now, the pathogen still, can get out of the host. Again, I'm like, there's lots of ways that it can get into the body. Well, there's lots of ways it can get out of the body. And if this picture looks familiar, it's because a lot of the ways that it can get in the body are the exact same ways that pathogens can get out of the body. Because pathogens can leave the body via any type of bodily secretions at any of these particular sites. And I'm like, you can have viruses and microbes, and anything that comes out of the body can be infectious, which is why you do have to be careful working with patients, because any secretion that they have, and I'm like, could be infectious with some type of virus or bacteria. Now, modes of transmission. Well, this is where if you've got a little area for notes, you may want to write a few things down. But modes of transmission is just how they go from a portal of exit, so one of these things, to another host portal of entry. How does it get from one place to another? So if you got sick, where did it come from and how did it get in you? And we group these modes of transmission into 3 groups: contact, transmission, vehicle, and vector. And I've got a couple examples for each of these, so you may want to write some of these down. My little note, because you may see them on the next quiz. Now, contact transmission just means it's spread from host to host by direct or indirect, and I'm like, or some type of droplet, but it's spread directly from a host to another host, and I'm like, via something. Now, a direct contact means it is direct bodily contact. So it's one person touching another person. It could be physical touching, your basic handshake. It could be kissing. And I'm like, it could be sexual intercourse. And I'm like, that is physical touching. And I'm like, that can be spreading some type of microbe from one person to another. An indirect contact is using an inanimate object to transfer the pathogen. So whether you share a toothbrush, and I'm like, which most of you are like, ew, it happens, especially kids. And I'm like, whether you shared a toothbrush or you drank out of someone else's glass that they were drinking out of. If it's kids, it's toys, all the time. One kid touches a toy, another kid touches the toy. It's why daycares spread diseases like crazy. Money. They say money is one of the dirtiest thing that is spread. One person touched it, dropped off a microbe, you pick it up. That's indirect contact. Even touching your basic door handle can be indirect contact transmission. And then there are droplets. Now, this just means the microbe will travel in droplets of water, and I'm like, for short durations, generally less than a meter, so just a couple feet. So I'm like, here's kind of my, droplet. And I'm like, if someone coughed or sneezed on you, those droplets don't go very far. Gravity takes over, they fall. And I'm like, but if they sneezed right in your face in a short distance, and I'm like, those microbes can easily travel on water droplets. Now, vehicle transmission means they get picked up from one thing to another through, I was going to say they call it a vehicle, something else that transports them. One, if they're airborne, that these particular microbes will travel in the air, usually in some type of aerosol, for more than a meter, which means they can travel larger distances. Examples is if you get some type of virus or some type of bacteria or fungus or mold in an air conditioning system, and I'm like, or an air conditioning unit in a building, it can transport all over the building. And I'm like, if you're sweeping a room, you might sweep up dust that travels all around. And I'm like, it can travel on that. And I'm like, anything that can just travel in the air for a long period of time. Waterborne transmission, and I'm like, this is if you are drinking contaminated water. Now, most contaminated water is contaminated with fecal matter. Yes, we will get into it. Everyone eats poop. And I'm like, but most of it's because water can easily be contacted with fecal. It's a fecal oral transmission. And then there's foodborne transmission. It just means the food you ate wasn't adequately processed. Someone had dirty hands, the equipment was dirty, maybe it wasn't cooked all the way, maybe it was poorly refrigerated, but somehow the food was contaminated. And then the last is vector transmission. Vector transmission is using some type of arthropod, an insect, that will transmit it. Now, the two types of vectors, and I'm like on how they transmit. One is biological, one is mechanical. Biological means that pathogen, and I have my mosquito as an example because it's a very common one, will transmit that microbe, but the actual microbe lives inside of the mosquito for a short period of time or for some stage. And I'm like, examples, malaria gets spread that way, West Nile virus, and I'm like, these things live inside of, these microbes live inside of the mosquito, and the mosquito bites you and transmits it. Now, a mechanical type of transmission is that the microbe does not live inside of the insect. Instead, it's getting transported by the insect. And so the microbe is on the surface, on some type of surface of the microbe. My most common example for mechanical transmission is in the summer, which feels like the next time you go outside, if you eat in the summer, when there are flies around. And I'm like, if a fly lands on your food, the question is, where was it before that? And I'm like, was it on some fecal matter? Everyone eats poop. And I'm like, was it on some other dirty surface? And I'm like, that it landed on it, picked up some microbes on its little feet, and I'm like, and then landed on your food, and now you just ate it. And I'm like, and so they can get transported around by the insects as well. Now, these two ways are considered non-communicable because they're not going directly from a person to person. And I'm like, the contact transmission is communicable. It's still going from host to host. Whether it's direct, indirect, or droplet, it's still transmitting from host to host. And I'm like, but people can get sick by drinking contaminated water or eating contaminated food, but it's not going directly from person to person. Now, a couple terms when we're using to classify infectious diseases. Again, is communicable versus non-communicable. Communicable, again, just goes from one host to another. And so when people talk about communicable diseases, is that you're infected with something, whether it's a virus or bacteria, you can spread it to another person because you shook their hand, coughed on them, sneezed on them, I'm like, whatever it is, and I'm like, you can transmit it. A non-communicable disease arose from outside of a host, And I'm like, so it came from somewhere other than a host. I mean, at some point it was probably contaminated by some original source, but it, your disease, you picked it up from something completely different than another host. Now, away from all my little terms on how we get diseases, and talk about some epidemiology, which just is, it's studying where and when diseases occur. Like, we always want to know if we're sick, and I'm like, where'd it come from? And I'm like, where are all of these diseases? And so there's a couple new terms when we talk about, where and how and when diseases occur. And I'm like, one, when we're talking about diseases, you're going to hear the word incidence and prevalence. Incidence is talking about the number of new cases a disease has in a particular area or a particular population in a given time. A lot of times I hear these terms when people are talking about AIDS, is how many new cases last year, for example. And I'm like, that was my given time. How many new cases of HIV were reported? And I'm like, last year in a given area or a given population. I want to know how many new people now have HIV that didn't have it before. That's incidence. Prevalence is talking about the number of cases, the number of people that have HIV. I'm using HIV as an example. Both new, whether they just got it last year or already had it 15 years ago. I want to know how many people in the world or how many people in a country or a state, and I'm like, have HIV. Not just who got it last year, but a total number. And so prevalence is really looking at everyone that has this disease. Incidence is how many new people are getting it. And when that incidence number goes up, then you know you've got a really big problem because you have more and more people that are contracting some type of disease. Now, when we talk about the occurrence of disease, some more terms, again, know these terms, put little stars next to them. Endemic means the disease is normally present. And I'm like, there are diseases, and I'm like, that are all over the world, and I'm like, they're worldwide, some, and I'm like, some diseases are more prevalent in certain parts of the world than others, but endemic just means this is the normal range of the disease. It's normally there, it's been there for a long time, it's nothing new, we just know that it's around. Sporadic is talking about irregular or infrequent. All of a sudden you have a random case of malaria. I don't know. I guess there'd probably be a lot of malaria down here. And I'm like, but if you have some new case of West Nile virus or whatever down here and it was never there before, or a case way up here and it's never been there before, that's when we get to the sporadic. Did someone travel somewhere? Why is this, disease all of a sudden found here? An epidemic means that the disease, which has already been here because it's still in orange, but it is now at a greater frequency than usual. And so for some reason, and I'm like, although the disease was here, that incidence, the number of people that are getting it, and I'm like, is on the rise. And I'm like, and this is when they're starting to get worried, like, why are all these people in this particular area now getting this disease? It's normally been there, but now we have this huge increase. That's an epidemic, when more and more people are getting it. And a pandemic is when that epidemic is now occurring in more than one continent. So it's not just an increase in a disease in one area in the world. Now that increase in disease is spreading, and I'm like, and more people are getting this disease all over the world. I'm like, this is was the big news, a few years ago, still in the news. I'm like, is Zika? Zika was always present in South America, but all of a sudden there's a rise in the number of people that were contracting Zika, and now it's spreading, yay, and now we've got even more on the rise. And I'm like, so it's pandemic means across, it's going across the ocean into more continents, causing disease. Now, when we talk about hospital epidemiology, we talk about nosocomial infections. Nosocomial, if you used to ask people, what's a nosocomial infection? They're like, no idea, because that is the worst word ever. They are renaming it, and nosocomial infections are now getting renamed as healthcare-associated infections, which sound more likely. Some textbooks, pamphlets, you're still going to see nosocomial, but we're slowly trying to weed that out and switch it and call it a healthcare-associated infection. Now, what a nosocomial or a healthcare-associated infection is, it's an infection that is acquired by the patients or healthcare workers while they're in a healthcare facility. So if a patient comes into the doctor because they're sick with whatever, one virus, but now they picked up another infection of something else, that's an infection they acquired while they were at the healthcare facility. Or if you guys who have jobs in healthcare facilities pick up a disease, whether it's a virus and a mic or something else while you go to work, that's a nosocomial infection. Yay for you. Now, types that you can pick up is usually a mic or Y, and a mic we can pick up healthcare or pick up infections in healthcare facilities. Mostly is because of the healthcare environment that is there. The people that are in a healthcare facility are generally sick people, and they're everywhere. And so you are exposed to lots of illnesses in healthcare facilities. Another, and I'm like, normal flora, and I'm like, that normally is not causing problems, can start to become pathogenic in healthcare facilities, mostly because they can get moved to somewhere where it shouldn't be. Like if you didn't clean a wound very well, and I'm like, the bacteria living on your skin gets inside of an open wound, causes an infection. And I'm like, or even the fact that in healthcare facilities, you're using modern medical procedures, whether it's using catheters, whether it's surgery, whether it's that ECMO that you saw in the video. And I'm like, these are all procedures. And I'm like, that, yes. And I'm like, they can be used or needed for survival, but microbes can live on them. And because they go into the body, and I'm like, they pose, a whole new threat for bringing microbes into the body. So we have to try to control all these. And I'm like, big time, because people don't want to go to the doctor and then get sick while they're there. And so it requires aggressive control measures. There's lots of precautions that are designed to reduce factors that result in disease, wearing gloves all the time so you don't have that bodily contact. But really the most effective way to prevent healthcare associated infections is hand washing. And I'm like, is getting rid of that contact. Now, 2 more slides that just talk about disease and public health. And I'm like, one, these are agencies that we've got, here in Wisconsin. And I'm like, we've got in the city of La Crosse, we've got national, we've got global levels, all these things. The United States Public Health Service, we have the CDC. Global wise, we have the World Health Organization. All of these different organizations are there to keep track of, and I'm like, all of these diseases. We want to know where diseases are spreading. We want to know, Zika moved to Florida. People in Florida want to know that. The World Health Organization is tracking things when they move around the world. United States is going to start tracking it internally. Is it moving? And I'm like, we want to know, where are things going? And yes, and I'm like, they share all this information through what's called a laboratory response network. And I'm like, it's where everyone can enter in, anyone that's sick with any particular disease, and we can track it all. Now, most of these public health agencies, their main job, and I'm like, and you may have seen some of these things locally, because La Crosse has their own public health agency, is they're constantly trying to, their goal is to limit or interrupt disease transmission. They don't want people to get sick. Whether it's they go around, they monitor water. They're monitoring the Mississippi River in the summer to see when it's unsafe to swim. And I'm like, they're the ones that are going to go around and monitor food safety and, make sure restaurants are up to code. They're going to reduce disease vectors and reservoirs. And I'm like, whether that's keeping track of mosquitoes and treating for mosquitoes and killing mosquitoes. They're going to immunize and enforce immunization schedules. They're going to be the ones that go around to schools immunizing kids for the flu, things like that. They're going to treat individuals that are exposed to contagious pathogens, whether putting them into isolation or not. And I'm like, and if needed, yes, have some type of isolation and quarantine measures. And I'm big in is just educating the public on healthful choices that will limit the disease. I've seen recently billboards that are advertising, like cooking food properly, making sure the microbes aren't happy in your food. Otherwise it's, eating healthy, getting exercise, washing hands, getting flu vaccines, all of these things that we can make healthful choices. That's what our local public health agency does. Nationwide they do as well. Don't see as much nationwide, but we do have our local public health agencies, all just trying to reduce that disease. So yay, end of the PowerPoint. And so again, you can pause me anytime you want in there.